Hi, I'm Samity. So in this demo, I'll show you how NoSQL injection vulnerability and how I fixed it in this Node.js and MongoDB application. So in this, you can see how user input is passed directly into the MongoDB query and attacker can send JSON operators like $ne to bypass this authentication. When I show you a demo, in this would return a user even without a valid credential. So this is the NoSQL injection. As a fixed, I have done this is the secure one. In this, I have typecast inputs and validate them. So MongoDB treat them as simple string, not the operators. So when I show you a safe request, now it's a status code 400. So server now reject this input and this injection attempt fail. In this, to prevent NoSQL injection, always we have to validate, sanitize and typecast user input before querying to MongoDB, and we don't trust the raw user JSON in queries. So in this, I'm going to show you how I fixed a CSRF cross-site request forgery vulnerability that is marked as our Node.js application. So CSRF usually happens an attacker trick a logged in user's browser into the sending unauthorized request. So since the browsers automatically include cookies and malicious side. For example, attackers can change password or update user data without the user knowing. So in the previous backend, it is originally trusted with a cookie-based authentication. The post, put, and delete endpoints were so vulnerable. So as a fix, I have used the CSRF middleware to generate a CSRF token. In every session stored in a cookie and export it via safe endpoint. So only the requests with the valid tokens are accepted. So in the front end usage, this is the front end usage in the api.js the setup, and in this you can see it fetch the CSRF token when the uploads and attach it to all the requests. Uh, in this also you can see how HTTP only true and same site cookies, and this prevent cross origin attacks. So now even if an attacker tries to forge a request, it will reject it because CSRF token is missing or invalid. Only our front end request with the correct token is succeed.
So hi, I'm Ramitu, and previous our application only had a simple login functionality with email and password. I added Google Authentication as a new security feature using OAuth 2.0 and OpenID Connect. I use Firebase as the authentication provider because it simplifies the OAuth integration and ensures secure token handling. And whenever user choose to sign in with the Google, Firebase handles the OAuth flow and return an ID token containing the user's identity information. On the client side, I capture this token and send it to our backend server. Also, on the backend, I verify the token with the Firebase to ensure authentication and then generate a JWT cookie for the user sessions. This JWT cookies is stored securely in the browser with the HTTP only. And secure flags which prevents the access from the client-side script and ensure it's only transmitted over the HTTPS. By implementing this, our applications can now safely authenticate user via Google maintaining secure sessions, maintaining with the JWT cookies, and it's also set the foundation for enhanced authorization and access control in the future. So the second vulnerability that I have found in XSS attack risk, when testing with the Snipe, I found that XSS risk where user control data like username and profile picture could be injected directly into HTML using dangerous set in HTML. For example, a malicious image tag could execute the script when rendered. In the new version, we remove the dangerous set in HTML completely. We now render user data safely using JSX like current user username and the current user profile picture, which automatically escape the HTML and JS. For extra protection, we use the DOM purifier to sanitize and dynamic URL or text before rendering. Example like that image DOM purifier sanitize technique methods and text, and so even malicious input is treated as a plain text. All firm inputs are controlled and update go through the backend API, which should be also validate and sanitize data. Overall, no raw HTML is inserted, images are safe, and the combination of React escaping plus DOM Purify makes the component secure against execution.
I am Devan. In Cleansy, I fixed three real issues that could burn you in the production: bad JWT handling, permissive pause, and weak login. I will show how found them and what I changed. Stack is Node.js, Express, React, and MongoDB. Auth is cookie-based JWT with Google Auth on top. I tested with DevTools, curl, JWT, IO, and OAuth. Plus, JWT, the original token shipped without the expiration time, issue audience verification trusted whatever was in the cookie. Cookie means HTTP only, secure same site and a message that is replay and CSRF bait. I proved it by decoding the token JWTION by sending tempered payload with the same signature. The server accepted. This is the earliest JW token. There is the only algorithm type and the expiration time. So I fix it by signing with HS256 and algorithm and adding expiration time issue and the audience and verifying algorithm issue audience and expiry in middleware. I set HTTP only secure in production as same site history can message from environment. Now a tampered token gets 401 expired token clean. This is the code snippets I use in the JWT generation and signing. Then we will move to the this is the after the JW token modification. So we will move to the another one course, the backend issues default course, which is basically allow everything for random origin. I send a pre-flight with the curl. The server replied with access control allow origin wide open that lets hostile sites call our API as if they were. I switched to an allow list from course origins, enable credentials only trusted domains and local methods headers to what we use now. Unknown origins get blocked pre-flight. This is the earliest narrow access control allow origins for the origins, and I limited to the origins. This is the code snippets I use. And third logins. Third logins, it was console logs with no reduction and no request IDs and no severity, and that hides incidents and leaks secrets. I added the PINO reduction for token cookies and password for request IDs and consistent levels. Failures and auth events are now visible and safe. I will show that code. This is the logs, information levels, and the service request events, request headers, and the body. These are the code snippet I use for the logger context logger, error handler, HTTP logger, logger.js. So that's all about my part. Thank you.
Hi, I'm Pradisha. I'll show two vulnerabilities I found and fixed in this web application. First one is broken access control. I started by scanning the backend routes to check which ones were exposed without the authentication. This reveals several sensitive endpoints like staff admin approvals, staff registration actions, checkout, and all the missing authentication checks. The app already had a JWT based middleware called Verify Token defined in backend utils. Any protected route should use this to enforce authentication. I updated the routes and the controller so that the all sensitive data endpoints now require verify token plus role to ownership checks. As you can see, I have added these. Before, without these changes, the endpoints like create new conversations are getting 200, and the forbidden, actually forbidden requests are getting 404 like not found. After fixing this, you can see this will get 401 unauthorized. In this case, the normal user cannot approve the staff registration. So I log in as a normal user and start to approve, try to approve the staff registration. It will give forbidden. Let's move into the dependency vulnerabilities. I checked this vulnerability issue with the npm audit command, and this flagged high severity CVE in node fetch pulled in through TensorFlow and Face API.js. To fix this, I removed the server-side use of Face APIs, so the backend is no longer depends on the TensorFlow. In the front end, I force node fetch to patch the version with the overrides, as you can see in the package.json. After reinstalling and reran the npm audit, the dependencies were fixed and got 0 vulnerabilities. In summary, I secure the app by enforcing the broken access control with server-side checks and front-end guards, and by cleaning up dependency CVs through upgrade and removals. Before and after logs captured and security folder